So, it finally rolls.
Awesome, look at that.
Our concept for the Artemis mobility platform can finally move and steer under its own power. If you don't know what I'm sitting in front of, this is Vertex. It's just one part of what we think the next lunar mobility system should look like, focusing on alleviating the strain that astronauts feel on EVA from their heavy backpacks. We think that this is an Earth version of what the lunar terrain vehicle on Artemis 5 and beyond should look like. We built this in-house at the UMD Space Systems Lab, but I'll touch more on this concept in future videos.
Crane up.
Is that good? Happy?
Yeah.
Okay, we're good. Today, we started the stress tests of our actuator systems, specifically our traction drive and our steering. All four wheels have independent steering, full 360-degree independent capabilities, over 600 foot-pounds of torque available to each wheel nominally, and over 1,000 foot-pounds available for brief moments. To make that happen, we have to pull a lot of current into these motors. We were concerned that the signals being sent to the steering motors were being interfered with by noise being generated through these giant drive lines that we have to send to the traction motors. So we wanted to stress test everything at full speed. On our first startup, we realized that we had uploaded the wrong PID values into our control system, so that resulted in this wheel going a little unstable for our first motions. Easily fixable, we uploaded the right values, and all of a sudden, everything was stable again. First up to test was crab steering, then front Ackerman, then turn in place, then rear Ackerman, then double Ackerman. We then went through the steering modes again, but this time while driving the wheels. As a side note, the traction motors are presently controlled via an analog joystick, which makes differentially driving wheels in different directions impossible. This is going to be rectified soon, connecting them digitally, but for the moment, turn in place is more of a test we only do on the crane, and soon we'll actually be able to perform the motion. Since everything appeared to be working okay, we decided to let the vehicle sit its weight on its own wheels and try steering again.
The other thing is that it can cause... What the PID is based on the mount?
The good news is it's quiet.
Yeah, it's great.
The next mode is turn in place. I feel the whole chassis moving behind me. Okay, next mode. Everything seemed fine until the motor driver for the rear left wheel said its Hall effect sensors were in an impossible state. These sensors are baked into the motor. They detect the phasing between the motor's stator and rotor and cannot be replaced. I didn't do anything.
with you?
Our temporary solution? Literally give it a kick.
So, what I'm going to do is I'm going to kick the steering motor, and I'm hoping it does something.
Don't die. Yeah, maybe we should just have someone follow the vehicle and kick it.
Why is this happening? We're still not 100% sure. But we only have a few weeks before our field tests, so it's our job to find the most functional solutions in this moment.
Yeah, give it a kick.
Okay, well, the fact that it can fix itself in this moment is better than it was before.
Yeah.
And maybe when it's at speed,
No,
and it's,
no, that's terrible.
this is gonna sound stupid. Turn the traction motors back on.
Yeah?
Just a little bit.
I'm with you, Charlie. All right.
Are you sure, buddy?
Yep, 100%.
Gotta take
All right.
off?
All right, Charlie, are you good?
I'm good.
All right, traction control in 3, 2, 1. Traction control is on.
Okay.
I am clear.
E-stop.
I have
Do you have an
e-stop.
e-stop? We thought that maybe since the motor started responding and correcting itself once it was moved just a little bit, maybe this wasn't the worst idea. So we tested it out on the lab floor.
Oh my god.
Okay, I misjudged what was straight, yeah.
Oh my god.
I'm trying. Will you push that chair just like a little bit right? Actually, maybe I could do it with the steering wheel.
Give us here.
Tiny little bit of steer.
I don't want it to rip itself apart. Like a rubber mallet? Oh, you mean like twist it, not like kick it like that.
There we go. No? Yeah, there we go. Recovered.
No way.
Yeah.
While we weren't able to get the motor to fix itself in these short back and forth tests, the floor we're doing this on is very smooth, slippery, and flat. We think maybe once we're hitting rocks and going up and down curbs and bumps that the motor will have a better chance of being able to correct itself. Now launching forward as fast as I
Okay,
can.
and now we're in Hall effect state error. Again.
We are?
Yeah.
Could it be a wiring issue?
Maybe.
Do we have some ideas?
Oh, she's
Oh, you
dead. She's way dead.
I read some other references, you know.
Are you getting encoder counts at all?
Yeah, okay.
Oh, duh.
I can read the data.
Wait,
this one.
we're now under voltage. Did someone push the e-stop?
Nope. We're still up.
Okay.
Are
I
you
have 2 green lights.
Alright, I'm gonna get in there and measure.
Okay. We still do need to find the root cause though, whether that be a motor driver issue, wiring issue, or something actually in the physical stack up.
Here's the thing. If it's not a wiring issue, pop it off. Spend another 2 weeks testing it, pop it back on. Alright, 2 weeks testing, 2 weeks taking it out, pop it back on. It's easy.
We figured while testing this out, why not open the doors and get us a little bit more testing room?
And then back up like 3 feet and then
Straight down.
Oh, that's insane. You know what? These wheels moved before the other one.
Charlie. Don't die.
You're just going over a little ramp.
Focusing on the front 2 actuators, since they seem to work pretty reliably, we wanted to validate that the geometry we had baked into our robot code would actually turn the vehicle as expected. And it worked very well. In just these small tests, we were able to see that we think the Ackerman angles are turning the vehicle correctly, which is a huge sigh of relief. We still have a fair amount of tuning left to do to make sure the steering motors and the traction motors all respond to a joystick as somebody would want them to. Today, everything was a little fast, a little jerky, so we're gonna try and smoothen everything out just a little bit.
Don't do that.
I'm not doing it intentionally, I'll say that. I've posted alongside this video a longer video of all of our testing from tonight, but with the boring bits edited out. So if you want to feel like you were in the room and you're interested in watching these tests a little bit more in depth, please feel free to check out that video. Yeah. Okay. Yeah, good. As far as next steps for us, we have a little bit more refinement to do, but we're off to field tests in the next week or two. We have to throw the giant robot arm on the back of the Rover, bolt it in, get somebody into one of our spacesuit analogs, and actually take it off-road, which is going to be very, very exciting. It's the craziest thing. It might actually work.